Okay. Welcome everyone to OAuth work group at IETF 114 in Philadelphia. So let's get going. We have packed agenda. So this is the not well. Please make sure you understand this. This governs everything that we do here at the IETF. So make sure you understand what's going on there. So we have one official session today. This is the one. We don't have another one as typically we do, but this time only one official session. But we have 3 side meeting sessions. So the first one Tuesday, tomorrow at 10. The second one is Wednesday at 10, and the third one is Thursday at 2. All of them Philadelphia South, which is just the room across here on the other side. A quick work group update. We request that RFC 9207 was published. So congratulations to Daniel and co-author. RFC editor Q has the JWK thumbprint URI and the JWT response for token introspection. And we requested the publication for the raw document, rich authorization requests. Roman is not here. He's going to be in and out, but he's aware of it and he's going to work on it. Okay, we have packed agenda, as you know. Step-up authentication, Vittorio and Brian will talk about this. Selective disclosure, JOT. Daniel and Christina will talk about this for 20 minutes. Then Daniel will give us a quick update on security BCP. Aaron will talk about 2.1 and browser-based apps. I will be talking about multi-subject JOT. Hirsch will be talking about token theft. Kelly will be talking about token and identity chaining. And Atul will wrap it up with the RPC security standard. As you can see, the time allocated for each topic is really short because we have really long list of topics. If we need to dig deeper into any of those topics, we will dig deeper into those on the side meetings, right? So based on what happened right now, we'll kind of adjust the side meeting agenda. So side meetings, the main topic, one of the main topics, Depop Shepard open issues. We're trying to push this forward and finish it. So there are few open issues as part of the Shepard review, and Brian will walk us through this, and hopefully we can wrap this up soon. Conformist tests and Sdks, Daniel and Joseph will have a discussion around this. We're attempting to do something about this. Again, as I mentioned, we probably have some deep dive into some of those topics that we discussed today. We want to have few open discussions around a few topics. For example, do we need a new RFC for a JOT, to update the JOT based on our experience so far? Brian did a fantastic presentation during Identiverse, and I think we have lots of lessons learned from that. So maybe it's time for a new RFC. We want to discuss post-quantum too. So just open discussion and any thoughts about this, what could be done here. And there is some issues around OAuth work group perception. Some people find that OAuth work group to be not easy to deal with. So I would like us to kind of have a discussion and see how we can be a bit more welcoming and accommodating for people that are not from the close, tight kind of group that typically attends the meeting. So that's it for me. Any questions, comments? If not, I will ask Vittorio to come to the mic here. And let me see if I can give you control, Vittorio.
Give me control. From the phone, with the phone?
Yes.
It's too complicated. I just like to berate you and ask you to move slides for me. Will you be so kind?
Sure.
Thank you.
Fine.
All right. Good morning. Buongiorno. In 10 minutes, I'll try to update you on the work that we've been doing with OAuth Step-Up Authentication Challenge Protocol with Brian. Can I have the next slide, please? All right. Agenda is ultra fast. I'm going to refresh for you what we mean by step-up and what's the scenario we're trying to solve. The proposal that we have, I'll give you an update on what we changed since the last time we met in similar circumstances, and then I'll mention some of the discussion items. As Rifat mentioned, we will probably have to deal with the Q&A in the extended meetings because I just don't have enough time. All right, thank you. So, resource servers can reject tokens which allegedly are still valid for many, many reasons, but typically they will have black box like risk engines that evaluate that that particular token is not enough for the operation that is being attempted, or there might be things in the call in itself, so beyond the token, that calls for different circumstances. Like, for example, I'm trying to buy an item which is very pricey, and it would be better for the resource server if the token would have been obtained using a higher level of authentication. Am I speaking too fast? Yes, no, maybe. I'm just trying to stay within minutes. Okay, so typically, in fact, what the resource server wants when they reject a token is a fresher token or a token that was obtained with a different, usually higher, authentication level. And today, there is no guidance for the resource server to tell the client the reason for which they don't want such a token. And there is also no in OAuth guidance for the client to communicate to the authorization server that they want something different. Next slide, please. So our proposal is ultra simple. We're just extending the collection of error codes in 1650 with the new code, which is insufficient user authentication. And in the corresponding header, we propose to send back from the resource server to the client parameters that are already defined in OpenID Connect, ACR values, and max age, which basically allow the resource server to ask for particular authentication levels or a certain freshness of a token. And then, given that we already have these in JWT access tokens, we want to be able to embed in the tokens the indication of the authentication levels that have been used for obtaining such a token. And we have already these in the JWT access token profile. We want to add these to introspection. And here is an ultra complicated back and forth. In the past, you got the animated version. If you want, you can get the recording from the last time. Here, don't have time to do this, but super high level, basically, you just have the client that hits the resource server using a token, which you cannot read, but it doesn't have ACR. Then the resource server replies with a new error code, insufficient authentication level, user authentication, and includes, in this particular example, the desired ACR value. We could have included in max age as well, but we didn't. This is just one example. Then the client gets this parameter and goes back in leg free to the authorization server, repeats the request for an access token, and includes the desired ACR. Presumably, the authorization server does whatever is necessary to meet that ACR level, then sends back a new token, and then in leg 5, you actually send the new token. As you can see, there is a little red thingy. That red thingy is the new ACR, and then happy ending, we get to 200. So that is the substance of our proposal. And of course, I'd be remiss if I wouldn't point out that the wonderful, wonderful graphic comes from the art and the genius of Brian Campbell. And what happened since 113? Well, first we got voted in. Now we are in the island, and this is an actual work item which we are working on as a OAuth working group. Philip and Peter have been very, very thorough, especially Peter. Thank you, Peter. And describing, mentioning their comments on the scenario and proposing improvements, which we tried to reflect. In particular, Peter pointed out that step up doesn't always mean step up. Let's say that the token that you obtain after the step up might not be a replacement of a token you already have. And so we clarified these in the spec. And Philip mentioned that it would be nice to have a mechanism to signal the fact that the authorization server supports this particular scenario. And so that's what we have done. We have extended the authorization server metadata with one element that comes straight from OpenID, which is ACR value supported. And we establish that the presence of that parameter indicates that the authorization server supports this specification. Now, the tricky thing, which we'll mention also at in the discussion points, is that by using that element, we imply that the authorization server supports both ACR values and max age in the request parameters. And it's not immediately obvious because the element ACR value supported only talks about ACR. So these should be a bit of a discussion, as in if we believe that we need something more explicit for ACR, or if we are okay with the current settings. Also, we extended the examples to also feature max age, and we fixed typos, and I really liked the joke in the acknowledgements, but unfortunately, we had to start putting serious acknowledgements there, so now it's gone, but there are the people that helped. Great, here we're displaying great trust in the future. We talked already about potential London discussions. What's left to do? Well, there is the IANA section, which of course we need to fill up because we want to extend parameters also for introspection. And we have to add the security consideration, like all the non-normative have a big TBD, so we have to do it. And then there is the thing that I just mentioned, like, is it okay to just use ACR value supported, or do we need something more explicit? And here is the interesting part. The spec, as it exists today, already does the job that it's meant to do. Like, there are no missing parts. And we are getting indication of people adopting this thing already. There was a comment in one of my LinkedIn posts in which someone said that the Department of Health in Norway is already adopting this thing as is. So I think that it's important for us to discuss this spec, so that if there are things that people think should be changed or removed or added, the sooner we do it, the less instant legacy we'll have. Because if we don't, again, this is something that the people deem useful and a problem that people do have already today. So they are using the spec in this form. So if you think that if there is something in the spec that you don't like, please make sure to chime in. If there is something that you believe should be in scope and you want the spec to address, please chime in, because otherwise we risk going really fast through the various stages and then be close to final and you didn't have a chance to chime in. So I think that's pretty much it.
Perfect. Thank you. Vittorio, any quick question, comment to Vittorio?
Personal thoughts?
Okay, perfect. Thank you, Vittorio.
Thank you.
Daniel, I think, or Christina.
Hello.
You want me to drive from here, or do you want to drive?
I think you can.
Okay.
Otherwise, I mess it up like I did last time. So
Okay,
let's try not to.
go.
Yeah. Thank you very much also for scheduling this. We're presenting on new work that's called Selective Disclosure for JWTs. And we, in this case, are Christina and I. If you have not seen the draft yet, that's what it's called. You can scan that. If you want to see the latest version in the Git repository, that's here. So much for the intro. Christina, I think the next part is yours.
Yeah, we'll quickly cover why do we need select disclosure for JOTs. I'll give an overview of the mechanism we are introducing, and then Daniel will go into kind of deeper dives of features we are enabling based already on some really good implementation feedback coming in. If you can go to the next slide. So really quickly, on the left side, you'll have the current flow where mainly JOTs are being used right now, where arguably there's sort of JOTs already selected or disclosed being transported. And what I mean is the claims included in the JOT is what user has already consented to. So this is very different from this emerging new model, which has been really prominent in verifiable credentials world, for example, or mobile driving license world, but not only limited to that, where the issuer is issuing a credential to the user with maximum amount of user claims. Like let's say issuer issued 20 claims to the user. And when user is presenting that claim to the verifier, different verifiers would request different subsets of those claims issued by the issuer. So it's unfeasible for the end user to go back every time to the issuer to get those credentials that have only subset of those claims. That goes against the promise of decoupling issuance and presentations to have all these new features such as, And so this is the main idea. In the flows, emerging flows that decouple issuance and presentations, we need the ability to use one JOT signed by the issuer and then use only subset of those claims as the different verifiers. And caveat that by select disclosure, we do not mean end user saying, I only want to present these claims. No, like it's relying party, the verifier, who says, give me those claims, and this application, the holder used by the user, can generate those subsets. Can go to the next slide. Oh, I have it here. Never mind. So yeah, so select disclosure, I received 10 claims and I want to, let's say, present only 2 or 3 out of those. Go to the next slide. SD JOT. And one thing that we really, Daniel and I have really been valuing is having simplicity as a feature so that it's really easily implementable for the existing JOT implementations. And we can explain why. So there are some existing selected disclosure themes, arguably, and that's kind of how we see selected disclosure for JOT's work. We're trying to keep it as simple as possible, and it is possible to set a disclosure without using advanced cryptography, but those, ECDSA, EDDSA curves you're used to. Formats, some formats in select disclosure are limited to binary formats. Here we're focusing on JSON JOT world, is valuing developer familiarity. For security wise, because it's in JSON and JOT, it is much easier to audit, whether algorithms are implemented correctly or whether there are any errors, rather than having it in the binary format. In terms of availability, Daniel and I have been amused. There are already 4 independent implementations of this work within 2-3 months we've been working on this. This is partially because you can leverage existing JOT libraries. And again, we're not limiting this to identity use cases. Going next, so you should be wondering, how does it work? We can go to the next slide because, in the JOTs, that's fine, you can go to the next slide. The 9th slide, because in the JOTs, as we all know, issuer signs over all of the claims. And what we did is, you go to the next slide. The idea is when the issuer is issuing a credential, issuer is not signing over the actual claim values. Issuer is signing over the hash of those values. And if you hash only the value, it becomes guessable versus attackable. So the issuer is actually hashing over the actual value and a random unique salt, which is unique to that claim value. So issuer signed credential contains only these digests. Next slide. But then, from an end user perspective, Another thing that issuer needs to send is this salt value container, which includes the mapping of actual claim values and these unique salts, which is not signed, which is a plain JSON object. And finally, when the end user is presenting this object, what end user does, it's a JOT. You can't really break issuer signatures. You cannot modify anything as issuer signed SD JOT. So select disclosure JOT in the blue one is being, on the left side, is being sent as is. Where selective disclosure happens is within the container. So user is sending only the salts and claim values of the claims that the user has consented to release. And that's how Verifier can verify and receive only the claim values that the user has consented and given the verifier in the release. And there's optionally holder binding. Yeah, I think this is a high-level overview, and Daniel will speak to details.
Okay, let's have a closer look at the SDJWT. Again, that's the thing that's sent from the issuer to the end user and then unmodified from the end user to the verifier. Next slide, please. This is what it looks like. So it's a JWT, obviously. May contain public key of a holder, so you can do holder binding or reference there too. That's really undefined or doesn't need to be defined here. The important part is at the bottom, you see two new claims. The one is called SD hash arg, which is obviously a hash algorithm, and then SD digests. That's the hashes of the claim values with the salted hashes of all the claim values. And if this would be a more complex object where you have, like in the OpenID for identity assurance, where you have nested claims and so on, then you would have one digest, usually per claim. We'll get to that in a moment. Yeah, so that's like the superset of all that can be released to the verifier. Next slide, please. And then, so that was only the hashes. And then we have this construct called the salt value container, which is sent from the issuer to the holder or the end user. Next slide, please. And here we see a construction that looks really ugly when you see it for the first time, but it works quite well, actually. What you see here is that for each of the claims, so we have the same structure as before, but the claim values, so to say, they are now JSON encoded strings. And these JSON encoded strings encode an array of the salt value and the plain text claim value. Now, why do we do this? This looks strange, feels strange, feels a bit dirty, but it works really well. Because what we need to do is we need to send parts of this, so whatever the holder wants to select, so to release, that we need to transfer from the holder to the verifier. And then the verifier needs to hash it, the salt and the claim value, and needs to come to the same digest as the one that is signed in the SDJWT. So we need to ensure that everybody hashes the same stuff. We could just send the salt value and the claim value separately as plain JSON values. The problem with that would be that we need to attach the salt and the claim value together to form a byte string that is then hashed. That's the first challenge. You need to have like a separator character and then escaping or some other form of encoding the salt and a claim value. In this case, we're just sending the whole thing that is to be hashed. So you already have a separation between the salt value and the claim value. Second challenge is that, no, please stay on that slide. Second challenge is that you have claim values that have more than one representation. And that actually affects almost all data types in JSON. So if you have a string, you can use some escapings to encode that string. For numbers, you have different encodings, especially floating point numbers. And then when you look at the address claim here, we even have things such as complex claims, so where the whole claim is another object. And all that needs to be encoded reliably into byte strings. And this is why we say, okay, the issuer does all the encoding and just makes a JSON string out of this and just sends the whole string. The verifier gets that thing, can hash it, comes to the same hash as in the SD jot if it was not modified in between, and then can just extract from this array the second part. This is an extremely simple implementation. It's super easy. You can do complex claim values as you like. You don't have to think about canonicalization at all. So it just works. Now the next slide, please. And as Christina already said, part of that salt value container that is sent to the holder is then sent to the verifier to actually check or to get the claim values. Next slide, please. And to check the hashes, of course. So you can see here, this is only a part, given name and family name in this case. For the verifier, the task is really easy. Check the signature over the SD jot that is sent in parallel to this. Then check that this thing here, which we call the release, is valid, can be signed. So you have to check the signature, the nonce, if you do bind it to the transaction and so on. And then, of course, and this is like the single thing that a verifier can get wrong, so please don't do that. Don't skip that. You have to check that if you hash the string for the claims, then you actually have the same digest as the one that is in the SD jot. This is the one thing that you can get wrong. We thought about how to avoid that, and we didn't come up with anything that works better than this. So we'll put some work into communicating that you really should not skip this part. And then, of course, after that, you can extract the claim value. The nice thing about this whole construction is that you can, as the issuer, select how you want to build your SD jot. You can, for example, if you have a complex claim like address here, you can say, okay, the whole thing can be released as a complete thing. So the verifier gets the complete address or nothing. Or you can do a deep dive and you can go into the individual elements here. This is relatively simple when you look at address. Next slide, please. But of course, in some use cases, you have very complex objects, like here in OpenID for identity assurance. This is an actual example from the spec, where you can see that you can do very complex things. Next slide, please. We already, as Christina mentioned, have 4 independent implementations. So you can go ahead and play around with this thing in your favorite language, if your favorite language is Python, Kotlin, Rust, or TypeScript. Our Python implementation is the one that we call the reference implementation. We built it, or we created it actually before the spec. And it's about 500 lines of code, really small. It evolves with the spec, so we try to keep it up to date, because we also have generated almost all the examples in the spec from that code. So yeah, it's hopefully useful. You can also plug your own examples into it if you like. So play around with it. Next slide, please. We also have looked at how you can format W3C VCs with this. We have a proposal in the issue tracker and actually also in the spec where, so the syntax is not final, but it will work out in the end. So this will also be covered. Next slide, please. What's the current status? What are the next steps? Next slide, please. We do have a functional specification practically complete, so there are no aspects that are uncovered yet. It's somewhat stable in the sense that we don't have big items open that we need to discuss. Obviously, there might be other input now. So let's see where this will lead us, but we're quite confident that this is already in a good state. We do have one new thing, that's the approach to also blind claim names, so that we can also hide what the names of the claims are, not the values only. Some missing parts in security and privacy considerations, but that should be relatively easy. And due to this, and also due to the simplicity, we heard from many groups and organizations already that they consider this a serious alternative to existing formats. It's easy to understand, it's easy to implement. You don't end up with just one Java implementation that nobody understands. And we heard that this will also be adopted in EU projects, nothing official that we can announce yet, but hopefully soon, and also by Microsoft. Next slide, please. Why are we here today? Well, JWTs were developed in the OAuth working group, and we see this as a tool based on JWTs that is useful everywhere in OAuth and OAuth-based technologies, so not tied to OpenID Connect, not tied to identity at all. We hope that it's universal, a universal building block for new technologies. For example, selectively disclosable access tokens or something like that. We don't know how that will look like in the end, but yeah, so these are the things that we can, well, there are more things that we can also imagine, so hopefully some good use cases there as well. And what I already said on a mailing list, we hope that this can be adopted by the working group. Next slide, please. So that we can work on this in the working group, get the feedback from the working group, and yeah, work on this together. Thank you.
Thanks, Daniel. Rick?
Hiya. Oh, that's really loud. Thank you for this. I think this is really smart work. I've only got one quick question about the string canonicalization of the JWT. Did you look at RFC 8785, which is the JSON canonicalization for crypto?
I did. But I think, or my impression was that if we go down that route, then we make the implementation much harder, because you have to implement all that stuff from that RFC as well. And now you can just use any JSON encoder. So you can just, so it really doesn't matter where it puts the white space, whether like all these things, it just has to encode the JSON faithfully.
Okay, yeah, good argument. My follow-on question, therefore, is don't you run a danger of someone saying, oh, I'm going to put a kilobyte of white space into my string, and then my tokens are getting really fat at that point, and that seems to be an anti-pattern?
Yeah, but you have that with any JWT, I guess. So as soon as you build a JWT, you can put.
So would you consider putting some sort of recommendations within, if this was to be adopted into the draft, to say, you know, if you're doing this string canonicalization, look at some of the best practices from 8785, perhaps copy them, but we're leaving you this get out clause.
You don't need to do canonicalization. So you just need to do faithful encoding. So
yes, sorry. Yeah,
but I think it would make sense to say avoid white space if you can, to keep the thing small. You don't need nicely formatted JSON in there.
Okay.
With new lines and tabs and so on.
Cool. Thanks.
Yep. Thank you.
Okay. Any other questions, comments?
Yes.
So, anybody?
You need to get in the microphone now.
Hello.
Brian.
Brian Campbell, Ping. I'm definitely in favor of seeing this work progress. I want to say maybe that you've overstated the stability just a touch. It's in good shape for this level of maturity, but I hope we don't, if we do proceed with adoption, that we don't use that as an excuse not to make necessary and important changes. Yeah, absolutely. I think I also wrote that on a mailing list. What I mean by this is there's no big questions. How do we solve X or Y that we know of? Yeah. We don't have, as far as we know, this has not been implemented in actual running production environments. So we are open to changes, and stability in this case just means that we don't expect that if we solve this issue that we have on our list, everything will change. Fair enough. Just a clarification. Yeah. Thanks. Thank you. No.
Just 1 second there, till Jemandeep, in the queue there.
In the online queue? No. Jemandeep?
The remote.
Okay, next, Atul.
Yeah, sorry. So Actually, I wanted to know the motivation of using selective disclosure JWT per se in the OAuth, because in the OAuth flow, we do not find it having much utility. It would be better if we can look at certain models of JWT in which if we issue a token to a particular user or an app, it should not be used by any other app. So maybe if we can prevent some kind of token stealing or a token reuse, that would be a more appropriate use case as far as the OAuth is concerned. So that was my thought on it. So maybe you can
One
elaborate.
second, Daniel. I'm gonna cut the line after Leif here, so go ahead.
Yeah, thanks for the question. I didn't get the first part, but I think I got the question. I think the token theft topic is orthogonal to this, so you need to prevent token theft in any case. The selective disclosure here is not meant as a way to protect data from malicious third parties that get into the flow and steal your token. It's meant to just release the data that is necessary to any relying party, and if that relying party, of course, misbehaves or becomes corrupted or something like that, less data can be stolen from there. But token theft is a different topic, I think, and we're not precluding other measures against token theft here.
Atul.
Great stuff. So just one minor question. In the SVC, why is the salt field why does it have the escape double quotes? I mean, couldn't we just use a standard format for the salt?
The salt is a string, so it's a base 64 encoded random number. And the salt and the plain text claim value form an array that is then JSON encoded. That's where you get the escaped double quotes from. So the whole thing.
So it's not a JSON array itself. Like the value could be a JSON array, and you could have the salt as one element of the array, and the next one is your escape, actual value, right?
Right. That's how we define it. So it's always in the SVC, you always have for each claim a string that is JSON encoded, representing an array of two elements, the salt and a claim value.
Okay. Thanks.
Oh, Leif Johansson. So I wanted to just address and comment on Brian's note on maturity. I think actually might be a good idea to try to capitalize on some of the EU projects that's going to run on this, to do an implementation report after this, right? Because we are in a position to be able to take this from sort of relative, we don't know whether this will actually work, to, well, we actually know because we've tested it. So take that opportunity is my advice, and I would suggest talk to Peter Altman, who is in the EU Toolbox group. And I think he is has his hand on the trigger to figure out whether this goes into the reference implementation of the wallet. And then you can have a wide sort of widely deployed base to point at after that.
Yeah, go ahead.
Just one sentence. Yeah, thanks so much for bringing it up, Leif. Yes, there is a really thorough assessment of SDJOT happening in, working with one toolbox, and I think that what gave us a bit more confidence. But yeah, thank you.
Okay. Okay, thank you all. So, quick show of hand, who read the document? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 people. 7. Okay. Can I get a number of volunteers also to review the documents later on? Mike, Leif, Yaron, Monty, Brian. Okay. Okay, so I'm going to call for adoption and see how much support here. And obviously, we'll have to take it to the list anyway, but I want to see kind of show of hand who supports adopting this document as a working group document. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I guess. Oh, 14. I missed a few there. Okay, 14, 15, about 14. Okay, good. Anybody against adopting this document? Okay, thank you. Okay. Okay, awesome.
You did 4 adoption.
Okay, perfect. Danielle and Christina, thank you very much. And we'll take the adoption to the list and take it from there. Okay, thank you. Oh, yeah.
I heard there's another. Yeah.
Yeah, absolutely. We'll continue that discussion on the side meeting.
Yeah. It's not this mic. Muted me as well.
How about now?
Test 1, 2. Yeah. Okay. All right, now I hear myself.
Yeah.
Test 1, 2.
Yeah,
So they can hear me and I can't hear me?
I think so.
Okay, good. And one bigger question arose, and that is regarding the Pixie support, whether the Pixie support should be mandatory for ASS. Next slide, please. So last time we discussed Pixie already. Unfortunately, what happened in Vienna stayed in Vienna, which means in this case that I didn't get around to making the changes to the spec quickly after the meeting. I did now, but yeah, should have probably done that earlier. In Vienna, we discussed that the rules around Pixie are probably fine as we have them right now. And in short, what we discussed there was that the clients are, with some exceptions, obliged to use Pixie. The exceptions is if you have a confidential client and you're using OpenID Connect, then under certain precautions, you may use nonce instead. Servers are not forced to enforce Pixie. We said that is up to the servers to do that or not. That's not what we say there. And we said that all of this needs a bit more explanation. That's the changes I did already. Next slide, please. Now, might ask whether we should, so currently we also have the sentence saying authorization servers must support Pixie. And so the question now is, do we want that in there? Because as we said, clients under some circumstances, when they use OpenID Connect, confidential clients, and take precautions, then they can use nonce instead. So what's the value or what's the damage that we cause by saying that authorization servers must support Pixie? Next slide, please. Currently, we say that every AS should offer Pixie, so to say, to the client. The reasoning behind that is that Pixie provides robust defense not only against token theft or token misuse, but also against CSRF. So as a client, as a modern client, so to say, I can say instead of state, or additionally to state, I can use Pixie. And that's more robust than just using state. The reasoning behind that is that the nonce may be contained in the authorization response as well. And if the attacker can intercept that, then the attacker can forge a new response with the same nonce and then inject that. Obviously, this requires an attacker that can intercept the authorization response. What's also nice is that the check for Pixie's authorization server enforced. And that's really something that we see in the Yes ecosystem with the implementations. So speaking from the experience we have there, and also experience that we discussed earlier when creating this draft from others, if you can enforce the check by an AS, which in this case obviously would be an additional check, then it cannot be skipped by the client. Or if the client starts using Pixie, the AS can say, okay, you also have to provide your verifier. That's really robust from our experience. Next slide, please.
So just 1 second here. So I see Justin and George in the line. Do you have questions about something that was mentioned here, or is...
Yeah, I had a question. I'm still struggling a little bit about state.
Sorry.
Sorry.
Go ahead, George. That's fine.
When I think about the state and the way we talk about people in implementing state, right, we tend to use it as a mechanism to ensure the requests are coming through the same device, the same browser, right, especially in a redirect-based flow. And I don't think anything in Pixie requires that. So are we, to basically say if we use Pixie in place of state, right, again, we're ensuring that only the entity that started the flow can obtain the tokens, but at the end, right, but we don't know if that bounced through a whole bunch of different devices or not. So is that something we're okay losing? Because that tends to be where state gets pulled in, at least the implementations I've heard of state. Or we need to add something to Pixie that basically says, when you do Pixie from, you know, a confidential client or from a backend web server, right, then stick some value in the browser so that when you get the redirect, you can connect them all together, which isn't technically required by Pixie. So anyway, that was my question.
So I'm not sure if I got the question correctly, but are you saying that Pixie might not be usable in like cross-device flows? Or
no, I'm saying Pixie doesn't have any requirement in it to basically track that the redirects are happening through the same device. Where in the use of state basically did require that. So I feel like we're losing something if we say do Pixie and not state. Now maybe in a certain context, tracking that the requests are coming from the same device is not critical. But in many cases, you don't want the request to start on one device and finish on another device.
Not sure what the wording around state is or was, but Pixie has this nice automatism where so whoever goes to the token endpoint has to provide the correct verifier. So right. you have to take care that you don't hand that verifier to anybody who should not retrieve.
Yes, I guess to me, the difference is they were handling two different aspects from a security perspective for the AS. And so I'm always a little bit concerned when we say, just do Pixie, don't worry about state, is basically the end of the thing. And we can take it to the list or whatever.
Yeah, let's continue that discussion on the list. Justin.
On this topic, agree with George that that Pixie and state address sort of parallel but orthogonal things, and that the advice should be to use the mechanisms for what the mechanisms are each meant for, and probably advice to use them together in appropriate ways. So sticking something in the browser so that you know that you're looking at the right Pixie value instead of trying to smash everything into the Pixie value is probably better advice in terms of sort of the layering here. I actually forgot that I was on the queue because I've been on the queue since the last presentation. And what I wanted to say there was that any call for adoption of SD-JOT needs to be done in the context of JWP, which is having a BOF, I think it's later today. I know that Daniel and Christina are aware of that proposed work as well. I just want to make sure that the rest of the OAuth working group is also aware of that, because I do see a very real possibility of two parallel efforts solving exactly the same set of problems in very different ways if we're not careful here. So I just want to make sure that everybody that's interested in that is tracking what's currently two different pieces of work. Ideally, I'd like to see us turn that into one piece of work if we can.
Okay, thanks.
Well, both good points. Regarding the first point, Mike posted this on a mailing list. I think this would be the right place to discuss that. So I would welcome both yours and George's emails there to discuss this further.
You said you did post it, or?
You did. I think you did. So time ago, but yeah. I think that's the place where we should discuss that. Excellent. And side meetings, obviously. Yeah. Next slide, please. I'm not sure. So I'm finishing up anyway.
Okay.
That's not much here.
Okay.
Also, if you have Pixie everywhere offered by an AS, this provides consistency for the client, so they know what to expect. Next slide. Let's discuss that then in the side meeting. And yeah, that's it from my side. I hope to finish up a -20 this week and to close the issues soon.
Thank you, Daniel. And if we need to discuss more in the side meeting, happy to do that. Thank you.
Excellent. Thanks.
Chris Aaron. Yeah.
Oh, look at that. All right. Hi, everybody. I'm Aaron Parecki. I decided to steal Brian's idea of putting photos on the first slide. This was a photo I took yesterday morning from the top of that statue. So here to start with 2.1, and then we're going to also get into browser-based apps, and I have only 15 minutes. So this is going to be mostly just a status update. And I hope that this will spur some ideas of things to talk about during the side meetings, but we probably almost certainly don't have time for actual questions about this stuff here. So last we talked about OAuth 2.1 was in Vienna, and we made a lot of progress on some of the open issues there. It was really great. The biggest change is probably this the whole concept of the credentialed client, and the result of that discussion was to take out that term and at the same time simplify the definition of what we actually mean by confidential and public clients, which previously they had a lot of additional meaning behind them that was sort of baked into a lot of the text. So the definition now is just confidential client has credentials, public clients do not. And there is no other assumptions made about other things about the clients, like how much you can trust them, because it turns out you can trust both confidential and public clients differently depending on a lot of other factors. Incidentally, that actually knocked out a whole bunch of the open issues that were open on the spec because there was a lot of stuff that was baked into that whole idea. Number 46 was an easy one that we discussed last time. So that's now, there's just a mention of that parameter and a reference out to the new spec. There is a new section. The editors were discussing this, and we realized that actually both the core RFC and the bearer token spec never actually explicitly say that a resource server has to actually validate tokens. That actually isn't spelled out. And it's kind of just an assumption that everybody makes because it's kind of, it would be a good idea. So that was in the context of this limited lifetime token discussion. And we realized actually there's nowhere that actually says you have to validate. So there's a new section. It's very short. That's what that says. That's the only really new thing. Everything else was things that we discussed previously. And then, yeah, the last one, there's the whole discussion around the redirect URI schemes of which is supported. So they're in the better order now, the more secure order, and the sentence that says ASs have to support all three is removed because that was really just that was in the native app BCP for ASs supporting native apps. Some other changes since the last meeting. There's a bunch of references that have been updated. So thanks to everybody who's working on that. There were some unused references and a bunch of new RFCs again, so that's always great. There's some more clarifications of some of the terms and other bits and pieces. These were issues that were already open from a lot of the feedback that was from Vittorio and Justin. So those are all linked there. The URL there will give you the diff of what changed in the source, which sometimes easier to read than the actual spec difference. And then I made a milestone link that links to all of the issues that were closed from this as well, in case you're curious about tracking all of the details. So some of I did publish last night, sorry, draft 6, which is snapshotting all of that stuff. Again, there's not that much. The only thing that's really new that was that section on validating access tokens, which again shouldn't be a surprise to anybody. Other than that, it was all of the changes that we discussed in Vienna. So future stuff, there are still several more things open on the GitHub page to discuss. And then there's 2 big sections left from the initial feedback on the very first draft, which is some of the security considerations still, and then the native apps section. I know Vittorio is waiting very eagerly on me to review that section. So that should actually probably, that'll be an interesting discussion when we finally do have that. There's still more to-dos on moving some of the normative language from the security considerations. That's been sort of an ongoing in progress of like pulling out the things that say you have to do this and putting it where it belongs, which is again part of the whole idea of this is now taking several documents and collapsing it into a shorter one. So that's basically it. I'm hoping that we can have some of these discussions in the side meeting. Don't know which day, but would love to have some time set aside to knock out some more of these. And I've got a couple of tags on the issues. I do encourage you to go like look at the issues that are open on there and then see if any of them stick out to you as things you want to make sure get discussed sooner rather than later. Okay. How long was that?
5 minutes, maybe.
Great. Okay. So, second document, new photo from also from the town hall, city hall. Browser-based apps. This is a draft that we started a while ago, and it turns out actually hadn't discussed in any of the meetings since April 2020. So that was one of the virtual interim meetings, and it is completely my fault for just not putting it on the agenda since then. So some quick refresher of this document. The idea is this document is meant to be recommendations for people who are building browser-based apps, also commonly known as single-page apps, using JavaScript frameworks in a browser. It is meant to be a sort of counterpart to the native apps BCP, which goes into detail about browser specifics and browser APIs that really are only relevant to JavaScript developers. So the last time that this was discussed was draft 6. There's been a little bit of work in between then and now. We just haven't had any presentations on it in any of the meetings. There are the big changes are here. The clarification around the requirement for Pixie is now explicitly says it's only about the access token issuance. There's the reference to the new ISS parameter. There's some more notes about the scenario of the single page app is actually on the same domain as the rest of the system, which is the sort of smallest possible deployment scenario of an OAuth system. And then there's in May last year, I did an update to pull the recommendations from the security BCP at that date into the browser BCP, which means there's now more changes to do from May till now. Any of the security BCP that's changed. And there are a bunch of just minor text cleanups and stuff. The big thing that is still in the works, Yannick has been very helpful and in adding this pattern. This was something that we've identified previously, and I think actually this was brought up at the last interim meeting. The whole idea of using a service worker as the OAuth client within the context of a JavaScript app is a pattern that exists. I've seen some documentation about it from people's implementations. That is now, there's a whole new section about that pattern as one of the main patterns. Basically, there's a section in this document that talks about like, here's a couple different options you have about how you can do OAuth in a browser, whether that's using a backend that is running server-side code, or if you're doing purely a single page app as the OAuth client. And then even within that, you have the difference between just JavaScript code running in the browser or a service worker being the client itself, which can better protect tokens. So there are a lot of trade-offs between all of them. So the whole point of this draft is to spell out the trade-offs, not necessarily say this is the only possible right solution. But this was a big chunk. It's still in progress. There's a couple of notes in that pull request about some details still to work out on this, but this is a great start there. And then the things that we're going to do in the future, the two biggest items are we need to make sure that it's up to date with the latest info in the security BCP, since that has been changing. And then secondly, there's a lot of people want guidance on how do you store tokens in a browser? Like, where do you put them? What do we need to know about that? And again, there's no right or wrong. There's just a lot of trade-offs for the different options. So it's important to spell out the trade-offs because people will end up making different decisions anyway. The two I put on here is like, you could just store them in memory where there is no persistence at all, which is technically the most secure. Or you store tokens in local storage because you want them permanently in the browser. And again, both of those have upsides and downsides. And there's a couple other versions of various things you can do as well. So we just want to make sure that we get all those listed out. So those are the big things to discuss. I'm sure a lot of people here have opinions. I see an opinion face happening in front of me. So we will, I'm again hoping we can have some time during the side meetings to discuss that. I think that's the last slide. So
okay.
Yeah.
Thank you. Aaron, do you have a quick comment, Vittorio, in the queue? Go ahead.
Thanks for the update. Very, very exciting. During the OSW, there was this big discussion about the fact that storing the tokens isn't as much of a problem, but is the acquisition of the token, which is the critical part, because like, you can be super secure where you save stuff, but if an attacker has the ability to use you to mint new tokens, then all that protection is pointless. And so there were like long discussions about the BFF pattern and intermediaries like the TMI BFF, which with Brian we suggested. So Would you contemplate the possibility of covering those things in the browser-based app spec in any capacity, from mentioning that they exist all the way to actually embedding, for example, the guidance that we were putting together for TMI BFF?
Yeah, definitely. Definitely, at the very least, mentioning all of them are a good plan. That's what I want to do with that new section. I noticed that we haven't had a lot of discussion on the TMI BFF document in a while either. So maybe it does make sense to combine these two and just put it in as, here's how you do this pattern, because it is basically one more option in the tool belt, and that will be a fine place for it. I'm happy to do that if that works for you as well. So
wonderful. Thank you.
Okay, awesome. Thank you, Aaron. Thank you all.
Thank you.
Thanks. I'm going to present now. 22 drive here. Okay. We're going to talk about nested JOT or multi-subject JOT or JOT embedded token. So the whole idea, the whole document started with the idea of a specific use case that needed a way to embed one JOT into another JOT. And the natural way or a natural place for it was kind of to start with a nested JOT. The nested JOT is a mechanism that allows you to have a payload of the payload of a JOT contains another JOT, but it doesn't allow you to contain, doesn't allow the outer JOT to contain its own claims. So after I kind of published that, I started getting more requests for different ideas or different use cases that need something like this. And it quickly becomes clear that there are so many use cases that need something like this, and the relationship also needed to allow you to embed one or multiple tokens into the JOT itself, and the relationship between those tokens and the main token. And the focus was mainly on that access token in that case. And then more recently, it was clear that there are even more use cases. And in this case, for the ID token to contain a JOT with multiple tokens like this. So, and for this reason, you see Dick and Giuseppe are now going to be a co-author of this document. We're going to work on updating the document and kind of spell out all those details. And so for this reason, we're not asking for adoption at this stage, just going to present the idea, the concept, the problems we were trying to solve, and maybe next time we'll ask for the adoption. But for now, just get some feedback. Next slide, please. Okay, so the goal is to define a way to allow you to embed one or more JOTs into one JOT. Next slide. So why is that useful? The obvious one is the audit trail. You want to be able to know who accessed what and when. In some use cases, it's very useful because it allows you to present information from those JOTs in real time. And we'll talk about an example later on. And obviously an evaluation, you get that token, you evaluate this, you can make decisions based on authorization decisions also based on the context of that token. Next slide, please. So I run quickly with the many examples of use cases. So a primary, a secondary related subject. So you have, think about a child and a parent use case, or a pet and an owner use case. You have a parent that wants to access the resources of the child. So that's the parent will be able to log in, and then when the resource gets the token, will get that token for the parent and the child, right? So next slide. Another example would be for multiple primary subjects. So you have, think about a married couple. The husband or the wife want to log in and perform some operation based on the ability to access the other side resources. Next slide. A third example is that delegation of authority. Think about an admin, for example, doing some operation on the user's behalf and accessing those resources, right? Next slide, please. So all the use cases that we mentioned so far were the tokens were issued by the same IDP. The ones that I'm going to talk about are different in the sense that tokens could be issued by completely different IDPs. And prime example is the STIR use case, which is a telephony use case. Think about a use case where A calls B. Again, we're talking about telephone here. A calls B, but B has a redirection to C. So when that happens, when C receives the call, they want to know that the initial call was actually from A to B and not directly to C. And in that case, what would happen that when the redirection service received that initial call with the token, they will create their own token and embed the original token into this token and then ship it to C. Next slide, please. Another example is the NSM project, which is a mechanism that tries to replicate the concept of a mesh, but at the layer 2 and layer 3 layer. So in that case, they have a bunch of middle intermediaries, and those intermediaries receive one token. They change the message, and then create a token, embed the original message, and hand it to the next intermediary. So another example. Again, these are different IDPs. Next slide, please. Another example, this is talking about now ID token here. So for example, you have multiple issuers that issue claims for the same subject. So an example, you get an ID token with that date of birth token that talks about the date of birth from one IDP, and professional accreditation, for example, from a completely different IDP. Next slide, please. And a last example is this is a use case in Italy. They have a multiple attribute authorities, and they need a way to embed multiple tokens in the ID token to allow the client to access those attribute authorities directly using those embedded tokens, right? And we'll show a few examples like this. Next slide, please. So what we're trying to do is just define a new claim and allow that claim to embed a number of tokens. It could be one or could be more, and define the relationship between those tokens, right? The main token and those embedded tokens. Next slide, please. So this is an example, like you see the child as, for example, this is a child and parent token. The child as the main primary subject here, and you have the tokens, and inside that tokens you have one token in this case that talks about the parent and the relationship between the embedded token and the main token. Next one, please. And this is an example of multiple embedded tokens. This specifically from Italian government. The way they're doing it. So you have, again, the main subject, and they have multiple tokens. Again, the one ID token that contains a number of special tokens that will be used with the authorization authorities, right? Next slide. So again, as I mentioned, this is just to give an update about the problem that we're trying to solve, the use cases that we have. Any thoughts about this would be appreciated. Hannes.
Mike Jones. First, a question about the example on the previous slides. Your tokens list, I expected the embedded JOTs to start with double quote EYJ.
Okay.
And not have unencoded claim values. So you're missing the signature in the headers. Is that intended, or is that just an artifact of what you presented?
I'm not sure. I will have to talk to Giuseppe about this and see what's why is that, right?
Okay, I'll assert that you want the full JOT.
Right.
You know,
Typically, we want
the
the full
three
JOT,
dot
yes.
separated
Correct.
bits.
Correct.
And you've done a good job demonstrating there's a lot of diverse use cases. It's not clear to me there's a lot of commonality between them, although having this syntax and letting people use it may be the best we can do. I mean, otherwise applications such as STIR will have to define their own claims for embedding JOTs for their own purposes, which is not terrible. I mean, the question before the working group in the draft, I think, is the commonality worth standardizing? Maybe it is.
Right.
Thank you.
Yeah, thanks, Mike. Any other comments, questions?
Yeah, there's George on the
George.
George, can you go
George.
ahead?
Yeah.
Yep. So I guess the only thing I wanted to add is the token exchange work that Brian and others did has the concept of an actor token, which, so I think I couldn't tell some of these use cases, maybe purely, claims related. Some of them may be things that you would want in an authorization model. And so I think we just need to make sure that if we pick up this work, we look at it from a lot of, like, when should these things potentially be present in access tokens, or these concepts be present from an authorization perspective as opposed to an identity perspective, I think will be an important aspect if we want to look at the whole space holistically.
Okay. Sounds good. Thanks, George.
George, can you also post this into the chat window so I have your correct question captured in the meeting minutes, please?
Yes.
Okay. Any other comments, questions? Okay. Thank you. Yeah, Hirsch.
Alrighty. Hey folks, first time listener, or no, long time listener, first time caller, already screwing things up. So do appreciate any patience. Here to do a bit of an informational session effectively on how GitHub is looking at token theft.
Keep going.
All right. How GitHub is looking at token theft and what we want to do to protect against it into the future. Bit of a call for conversation and perhaps progress at the end of this. Next slide. And just for reference, I do identity at GitHub. Next slide. So the reason that we're bringing this up is that we're seeing a different kind of attack than what we are typically reading about when you read the token binding specs or typical expectations of what an attack is. We're not looking at or not seeing rather, attacks in the wild that are based off of XSS or getting malware onto somebody's desktop. It's actually attackers breaking into trusted cloud providers or integrators to steal masses of tokens in order to then attack the real victims. So all of us trust a certain set of providers out in the world to do CI/CD for us, run actions, and all of them have access to our code bases. So what these attackers are doing is coming in and stealing access to your code base so they can then look into your code base and find secrets to move laterally into your infrastructure and pull off the actual attack that they wanted to do. And so this isn't about preventing the actual attacks where they're getting into your infrastructure. That's Spire, Spiffy, all that kind of stuff. And it's not about preventing the attacks on those cloud providers in the first place. We're really looking at mitigation. What happens once they've gotten into your cloud provider or your integrator, and what can we do to make that less bad? Next slide. Obviously, just some kind of tokens that you can lose. This is mostly for reference. Next slide. But all of those tokens do share some similar weaknesses that we're kind of focusing in on. None of them are sender constrained, right? Basically, no tokens out in the wild right now actually have binding. A lot of them have way too long of a lifetime, and most are over permissioned. This is a common pattern we're seeing across all of the tokens that are being stolen. Next slide. So sort of as our advice for app developers, if you are going to be one of those integrators or you're going to be a developer whose code base is being broken into through those cloud providers, we do have some suggestions, right? Encryption at rest. Once that attacker gets into your system and dumps all of your tokens, please don't make it easy for them to use them. Make them steal something else that is better protected, like your decryption key. Actually use expiring tokens. What we see out in the wild is that there are tons of infinite lifespan tokens that get committed into code bases. If you are going to be committing secrets into your code base, please turn on secret scanning of some kind and get them back out. This was a major problem whenever we look at attacks that run through GitHub against victims. If you turn on secret scanning, there aren't any secrets inside your code base to steal and abuse. And then finally, you know, and this is kind of the guidance that we're going to be providing to people who want to integrate against GitHub. Just don't have credentials to lose in the first place. If you can use workload federation, store keys inside of an HSM, please do it, because that is just one fewer thing for you to lose. Next slide. The bulk of what I wanted to talk about today was really what are we as service providers, as token issuers, able to do to bring app developers and integrators into a better, more successful place. Next slide. There's a lot of easy stuff-ish that I think we can get done today. So IP allow list for applications, having confidential clients, right? The focus of most of this is confidential clients. Have them declare where they will be using tokens from. That ups the game from I steal your tokens and use them to I steal your tokens and now have to still be within your perimeter to use them. That is extremely powerful. Limit non-expiring tokens. So this is something that certainly we want to get done over at GitHub. Start limiting the use of infinite lifespan tokens, eventually deprecate those, and make those go away. Have everything be proper, like OAuth rotating access tokens, or even better, support workload federation, and support people not having client secrets, not having tokens that they are storing at all. We want them to be using their infrastructure identities as authorization against our services. And then finally, if you are issuing tokens, please register those tokens for detection with anybody who will do secret scanning. A little bit of that on next slide. This is pretty straightforward, right? This is basically just upload a regex, and then secret scanning teams can find your tokens very identifiably. If you add checksums, high entropy, you can make this very low false positive as well, which means that when developers turn this on in their code bases, they aren't going to be swamped with a bunch of stuff they want to ignore. Just to give an idea of the efficacy of this, we've had customers turn this on and find thousands of secrets inside of their code bases. Like, this is a real problem that we actually want to use to combat token theft. Next slide. And then kind of the meat of the topic is token binding, right? Like, every time there's a big token theft that hits the news, people say, so why were they able to use those tokens? Why bearer tokens? They suck. Let's fix that. Let's talk about that. Next slide. So this is purely from a implementer's perspective that actually is told to go fix this. 8705 is dead. We're not going to implement it. We're not interested because it doesn't support enough platforms. It doesn't work across all of our platforms that we care about.
Yeah.
Sorry, 8705 is MPLS binding, right? This is channel binding. It doesn't work because it doesn't work inside the browser anymore. And so if we have to invest in that, it doesn't get us far enough. Mobile apps, though, and sorry, that is to say, though, Depop seems to be offering us a lot of what we actually care about, which is device binding, making sure that the device we gave the token to is the same one using it. Seems to be working pretty well for mobile apps, right? This is something that we can reasonably go out and implement pretty cleanly today. Desktop apps, you can start using the macOS keychain. You can start using TPMs to bind keys. But because there's no strong application identity, you get medium IL privileges, you run as user, and you just say that you're the GitHub CLI, or you just say that you're Chrome and you can get those keys. And well, okay, that's not great. Confidential clients. This actually seems fairly reasonable from a technical perspective, how we can start having confidential clients prove that they are still the same client that was sent the token. However, there's no profile for this. There isn't a dedicated way that we have seen to actually go implement this. And then finally, web apps. There's like web crypto API, which is great. And if you can XSS the tokens out, you can probably XSS out a use for them as well. We'd love to see some stronger device binding there because, next slide. Kind of our risk profile that we're looking at is assume they've gotten into your database, assume that your site has XSS. How do we still bind the tokens given those two things? And so what we're looking for is really get them, force attackers to get to the next level, which is infrastructure compromise, either on the desktop that your application is running inside of, either on the browser or as an actual desktop app, or into your web app infrastructure, right? They need to be able to stand up a microservice inside of your trusted perimeter. That's the bar that we want attackers to have to meet in order to lift and steal and use tokens. And right now for web apps, it seems like that's hovering right around, like we can do 2, but not 3. So next slide. There's also a lot of stuff here that seems like it's not quite solved yet. And again, this is basically just, please come talk to me. I'd love to help figure out how we can solve these. One is I'm calling it referred binding. I think there's probably better terms for it, but when that authorization code is sent to a confidential client and then they have to respond with a cookie that is somehow bound to the same browser that got that authorization code, there seems to be some weaknesses there around, is that the optimum time to go steal something and replay it? TPM rate limits. This works fine if you're like on a Windows device, right? You can get 10, 20 signatures a minute out of that thing and everything works fine. If you have thousands of users and you need to be creating signatures off of some VTPM as a confidential client, you start hitting rate limits really quickly and you start having to do stuff like shard your activity by your TPM as a bottleneck. Understanding how a profile for confidential clients can reuse certain signatures inside of Depop would be really interesting. One that is particularly interesting to us is sort of hosted workloads or shared execution. So if you're a CI/CD system or GitHub Actions and you are requesting tokens for a workload that you are hosting, how do you bind those and what do you even bind them to? Do you hold those and then sign them right before you hand them to the workload? Do you run a sort of shell around the workload and then sign things on their way out? Open questions here that we're not sure how to solve. And if we can't bind the tokens that we're handing to our workloads, that feels like a vulnerability. And then finally, the privacy element here. Can we actually ship this to all of our users if we're saying, hey, we want to durably identify your device? There's a whole separate community and kind of zeitgeist right now around making sure that's not possible. So not sure where that tension is. Next slide. So call to action, really. Love to see a confidential client profile for Depop. And again, very happy to work with you on this and figure out how we move this forward. Working with the browser vendors to bind keys from the operating system up through the browser into web applications so that we can hopefully heighten some of the security guarantees there. And then finally, really just guidance and standards for like, what does token binding look like in a successful deployment? And again, we're there to both help move that forward and be a reference. Next slide. I guess that's it.
Okay, awesome. Any quick comments, questions?
Mike Jones, on your last slide, what does browser support for Depop key protection mean?
Right now, like web crypto, will have non-exportable keys, but it's not clear that those are actually being sunk all the way down into the OS and device identity.
They're not.
Yeah, getting that support would be great. Yeah.
I'll talk to you later.
Vittorio.
I think that doing something with a browser for supporting browser artifacts like cookies and similar, given the demise of token binding, would be very good for the industry. And I think it's a very good idea. And I'm looking forward to see if your proposal develops. And you know that we work with browser vendors for other reasons. So please feel free to use us as the liaison as much as possible.
Yep. Thank you.
Okay.
I had a question. So,
sorry.
I'm audible? Yeah.
Go ahead. Go ahead.
Yeah. So I had a question. Basically, sometimes we have seen that even for the native apps, the authorization code flow is used. So many times the client secrets are embedded into the desktop apps or the native apps. So are we looking also at ways to bind that client secrets in some ways, or is it restricted to only tokens?
Yeah, absolutely not. Actually, I was a little bummed to see that Aaron had talked about removing credentialed clients from 2.1 because there was some interest in like temporary credentials that are assigned on a per application basis. Had no idea how that was actually going to function, but no.
Can I respond to that?
Okay, quickly, please.
Just very brief. I did mention this last in Vienna, or not in Vienna, right after Vienna at the OAuth security workshop about the possibility of turning native apps into confidential clients using other mechanisms that exist. So we'd love to talk about that further and see what your interest is in that.
Yeah, absolutely.
Yeah.
Awesome. Thank you very much. Appreciate it. Is Kelly here?
I'm Kelly Bergen from the MITRE Corporation, here to talk about token and identity chaining between protected resources.
Can you get closer to the mic?
Oh, well,
Just a little.
oh, really? Okay. All right. Hey, next slide, please.
Come on.
So some background, a couple of years ago, MITRE published some profiles for the OAuth 2.0 and OpenID Connect. Mostly it was adding security requirements that were optional in OAuth 2.0 as mandatory. And we also have in our target environment is a enterprise environment. And so clients and servers have PKI credentials that they use to authenticate to each other using mutual TLS. So now we're working on extending OAuth token exchange in a case where you have a protected resource in one environment that needs to access a protected resource in a different organization's environment. And so next slide. I presented this before last year to a couple of people in a couple of forums. And I'm back to update you on things. So in a single ICAM environment, both protected resources are in the same ICAM ecosystem. So they trust the same authorization server. But I want to talk today about the multi-ICAM ecosystem case where you've got a protected resource in one organization that needs to access a protected resource in a second organization. Excuse me. So we make use of OAuth token exchange, but in a way that's more of it's a mix of a profile and an extension to token exchange. So the goals for this week are to get some feedback. I sent the document to the mailing list, and we haven't had a chance to get it public released for our website yet, but I'm happy to send it to you, anyone who is interested in reading the document. So I'd like to get some feedback on the profiles as well as a new claim that I'm defining today. Next slide. So some requirements that we have are that the when PR2 in the second organization receives the access token that it received through token exchange from the first protected resource, that token needs to have the client ID and the confirmation claim related to a PR1 so that it can do some verification in the presentation of the token. It also includes an actor claim, which includes the subject as PR1 and the issuer of that particular token, and all previous actor claims. So you can imagine this may propagate from PR1 to PR2 to PR3, and so that the final protected resource can verify the identities of everyone participating in the exchange. Next slide. So here's a diagram that may be helpful. We have two options for this multi-ICAM ecosystem situation. The first one, the client receives its first token, presents it to PR1 in the first organization, but PR1 needs to access PR2 because that's where the data is housed for the response to the original request. And so PR1 simply does token exchange with its authorization server in organization 1. And presents that token to PR2 in the second organization. And then PR2 uses, it validates the token and ID with its authorization server AS2 in organization 2. And because we have this attribute sharing infrastructure, AS1 and AS2 can communicate with each other out of band so that AS2 can validate the token that it received, because the first token was generated by AS1, and so there needs to be this underlying attribute sharing infrastructure for the two authorization servers to communicate with each other. Now the next slide, please. The use case that we've had problems with in the past, and some of you may recall, we proposed this, it didn't have a solution, so now I'm proposing a solution. So in this case, when PR1 performs token exchange with its authorization server AS1, instead of AS1 generating the token and returning it, it actually pauses, generates a JOT assertion, sends that to AS2, where AS2 generates the token, sends it back to AS1, who then returns it to PR1, and then everything is fine from there on out because PR2 can validate the token because it was generated by AS2. However, this requires some custom processing at AS1 because I kind of flew past it earlier, but we require for PR2's validation of the token that the client ID and CNF fields in the token that's being presented to it identify PR1. And if you just do this as is, that's not going to be the case, because when AS1 generates that JOT assertion, the token it receives should identify AS1 in the client ID and CNF fields. So to fix this problem, we are proposing a new claim. Next slide. And this claim is chained ID, which basically just passes those two bits of information, the client ID and CNF fields from PR1 to AS2. And then AS2 does a little bit of, it populates the ASX sub and odd claims according to the specs, but instead of filling the client ID and CNF fields with the values of AS1, it uses the information that was passed to it through the chained ID claim to populate the client ID and CNF fields in the new access token, so that when PR2 receives it, it can validate the token should be coming from PR1. And so that's my proposal for a new claim. And next slide. I'd like to get some feedback on thoughts of whether this new custom processing at AS1 is reasonable, and whether this new claim could be valid or useful to anybody else. We do have some implementations. We've got one in Ping Federate right now that uses custom processing at AS1, like I mentioned, and we're working on Keycloak next. And so I know we don't have a lot of time today, so I'm happy to be available the rest of the week to discuss any interest in these profiles, as well as what you think on this new claim.
Hi, sorry the Meet wouldn't let me log in. Is there a draft for this?
Yeah, so like I mentioned, we have to go through a public release process, and so it hasn't been posted to a URL yet, but I can send it to you. It's been posted to the mailing list. I included it as an attachment, and I don't know if it got scrubbed on the way to you guys.
Okay.
But I'm happy to send the document out to anyone who requests it.
Okay. So my general comment, as soon as I saw client ID, my thought was, what's the format of that? Is there a specified format, or is it ambiguous? Is it just a opaque string?
There's no specific
So
format.
I want to caution anyone who likes the idea of leaving opaque strings. I want to use the cautionary tale of the subject field of X509 certificates. We had to go and invent a whole nother extension, subject alt name, which has a structure which has several different types, so that you can partially unscrew the mess that was created by having something that was completely opaque. I think it's perfectly fine if you have types, and one of the types is this is an opaque blob, but not having a way to indicate that there is a structure is a recipe for pain going down the road later. Thank you.
Got it. Thank you.
And that was Rohan, if you don't know.
All right. Thank you.
Any other comments, questions?
Sorry, Rick Taylor, I should probably use the Meet Echo app, but I've just jumped to my feet. I'm just I'm observing. I haven't obviously read this draft because it's difficult to get hold of, and I haven't read Rifat's draft. But isn't the solution to this this claim, this kind of delegated authority that AS1 is saying? I'm just thinking off the top of my head here. Isn't the solution to what should go in this new claim field is actually you're embedding a subtoken? So there's some kind of recursive element here where that delegated claim, as you're moving between authentication areas, could be captured by the formats you're talking about, Rifat, in terms of it's just a token within a token. I think you guys should talk about this.
I think we should think about this and talk about this. That makes a lot of sense, actually.
There you go. My work is done.
All right. Thank you. I appreciate it.
Thank you. Any other comments, questions?
All right. Thank you.
Okay. Thank you, Kelly. Atul.
Yeah, hi everyone. My first IETF as well. So thanks
Welcome.
for having me on the schedule.
Yeah.
I'm Atul Tulshibagwale. I'm CTO of a company, relatively new company called Signal, and that's my email address and Twitter handle there. So let's jump. Sorry. Yeah.
Yeah. If you wanna.
Yeah. Let's jump right into it. What I'm going to talk about today is more of a sort of, do we need something like this? Like trying to have a discussion about whether there is a need to standardize something at this level of the RPCs, which is sort of somewhat lower level to what we are used to talking about. And the other question then that brings up is this the right forum, or is there some other, working group that this should be discussed on, right? So how RPC security seems to work today, in most cases, I know some companies do things differently, is that at the top level, you get an sort of a service that is consuming an OAuth token, and then there's a whole bunch of microservices that hang off of that, and all that context is lost at the top level itself, right? So what you then do is extract whatever sort of user ID or information you need to do from that OAuth token, and then just make an RPC call without any security other than maybe a mutual TLS connection between the microservices, right? A very typical approach to doing things today. The other problem is that when you call a third-party API, we had the presentation before where you have an API key that is very powerful because when you call that third-party API, you're using a token that could be long-lived, could do things on behalf of many users. And as a result, by using that key, you can pretty much do a lot of damage on the tenant that you have in that third-party platform that is providing that API. And the third problem that we see is as more multi-cloud deployments proliferate, where your own tenants are spread across multiple cloud platforms, you still need some security model that sort of crosses those boundaries. And maybe you're using your own kind of API keys, or you're maybe creating some specialized kind of TLS connections between your VPCs. But again, all of these things seem to have a few problems. And let's go to the next slide where I talk about what are the issues, right? And basically the issue is that if you have a VPC compromise, you end up with like a terrible amount of power that you're offering to any attacker. Like for example, I'm not trying to pick on any one company, but there's a company called OneLogin where an attacker entered into their VPC. That attacker was in their VPC for months, and that company unfortunately held the credentials for a lot of users for thousands of other companies, right? A massive compromise resulted from that. I mean, I don't know the extent of the compromise, but I can imagine the possibilities there. But there are various ways in which this can be achieved, right? You can have a software supply chain attack where your microservice within your VPC gets compromised, and then the attacker has control over your VPC in that way, right? Like the person from GitHub pointed out that you could have a dev chain issue where your GitHub has been compromised, and from there your VPC gets compromised. Or like in the case of OneLogin, the privileged user who had access to the VPC at an administrative level, their account got phished, and that attacker was able to enter the VPC in that way. So I think we can imagine there are various scenarios in which VPCs can get compromised, and what we would like to do is make sure that even if such a compromise happens, that the extent of the damage can be limited, right? And so the same thing where if you're using a third-party API, let's say you have a tenant, and your tenant uses some custom process to call a Workday, like an HR API to onboard people onto your system. Imagine if somebody was able to get into your VPC and actually use that same key to create fake employee that had a lot of access in your sort of organization, right? So these API keys are very powerful, and they somehow if you can restrict that power, that would be good as well. And the other problem, like I said, in your multi-cloud deployments, you may have to roll your own security today, and there's no standard for doing that. And one important thing is that the OAuth token that comes in has a lot of context. It has basically a scope. It has a user identity associated with it, and that context is lost in subsequent calls, right? So if you can somehow preserve that context all the way through to the lowest level, to maybe at a database level, that can limit the attack possibilities quite a bit, right? Next slide, please. And so while I don't have a solution, I have seen some solutions previously. I used to work at Google and really admire what they've done internally. But what I feel is that a good solution would preserve the identity and scope at any level, right? It should work the same across your 3P APIs and your multi-cloud deployments. So if you have a standard, you can carry that identity and scope, restrict the scope even further if you want, all the way through, across different cloud platforms, down to your lowest level, database. And the possibility of compromise through a VPC compromise becomes much lower now, because even if you had a fake service in the VPC, you're not going to be able to do much until you have a user credential token with a specific scope on behalf of, so that you can act on behalf of that user. Now, obviously, you need at every level, you need this to be, independently verifiable, so that you limit the amount of trust you're having between your own microservices. And then if I just grab a token, I shouldn't be able to use it, sometime later and replay that user's ability. And because we are talking about RPCs, which are like happening much more frequently than like an OAuth token exchange at the higher level, you need this to be super efficient, right? Next slide, please. And so, what are possible solutions here, right? So, you need to be able to come up with a token that is specific to users and scopes, right? And you should be able to, further restrict the scope and downstream calls, right? So that a service cannot like suddenly switch the context. I'm operating on behalf of user A, and they're asking me to make this change to their sort of personal email address or something like that, and I can't switch it to be like user B, and they're trying to change their social security number or something like that, right? So you need to be able to do something like that. In order to limit replay, you may have to go with much smaller, much shorter lived tokens, and I think something that was proposed before as well in today's session. And you should be able to bind these tokens strongly between the originating and the destination services, so that you cannot reuse those tokens for something else than what they were intended for. And somehow achieve interoperability across cloud boundaries by maybe token introspection, or sort of having a common root of trust, and then being able to verify those tokens when they're received, right? So this is all I had. I know I may be finishing much more quickly.
That's fine.
Yeah, and that's somewhat by design, because I want a lot of discussion even today on this, and okay. Hopefully you have some questions.
Okay, I see Ben. Go ahead.
Hello, looks like I'm talking. Great. So I have several points to make, actually. And I guess the highest level one is just to get a common understanding of what we mean by RPC. And like in the talk, it sort of sounded like you have as at least the main thing you're thinking about when you've got like a big API that is facing to like maybe the actual users or some other services, and then the implementation of that API has to go off and make a bunch of other internal calls to a bunch of internal microservices. And you're worried about you're mostly worried about these sort of internal RPCs that are to these microservices, because the backend implementations are highly privileged so that they can call all of these microservices on behalf of the end user. And that sort of brings up two main topics, one of which is the sort of confused deputy problem, where you need to make sure that these backend microservice calls are bound to the specific user and scope that you want. And that's a problem that we already have to solve today. And the most common way that we do that is sort of an in-band signal of, I'm making this API call on behalf of this user or whatnot, which is not great, but it sort of gets the job done, but it's really something that you have to be doing already. And then the other topic that I heard was that because this backend implementation has to call so many microservices, it has very privileged credentials there. And so if the VPC that's hosting that service gets compromised, then you have a very privileged credential that's compromised as well, and you don't necessarily have a good way to protect or recover from that. And that's also an interesting question to consider. And one of the things that comes to mind as a potential approach to combine a solution for all of these would be if the highly privileged credential that the implementation has, the service implementation has, is not directly usable for calling the microservices, but rather you have to go to some other credential token issuing service and authenticate as yourself as this highly privileged user, but also at the same time present some evidence about the request that you are servicing, so that your short-lived credentials that actually let you call the microservices can then be more easily bound. And I know that's going to be hard to do efficiently, which I think you specifically raised. but it's also the only thing that really comes to mind as a way to combine all these properties. And I just dropped a lot on you, so ask clarification if you need anything, and I'm happy to hear your thoughts.
Yeah, so you're right on in terms of sort of what is the problem we're trying to solve. There's one more aspect which is sort of, in addition to the microservice RPCs and the third-party API calls, there's also the multi-cloud aspect of this, where you have multiple VPCs and different cloud platforms, and sort of you're trying to solve the similar problem, but it's just within your sort of infrastructure, if you will. But yeah, you're right on in terms of like the scope of the issue that we're trying to solve, or we're trying to. I'm trying to bring up over here. Yeah. Was there anything specifically you wanted me to answer?
I'm kind of curious to hear your thoughts about how this relates to existing solutions for the confused deputy problem, because I would hope that people are already solving the confused deputy problem. And I don't know if you were thinking this would build on top of that or be a different sort of solution.
Right. So I guess I'm aware of a few proprietary solutions today that solve some of these problems, but I'm not aware of something that is adopted as a standard.
Okay.
If you want to point me in that direction, I would love to go research something.
Yeah, I think I'll drop a link in the chat to some Kerberos related work that covers some of the things I was talking about, but I don't know of anything that's OAuth specific.
Sure. Thanks, Stan.
Okay. Thanks, Ben. George?
Right. Yeah, I was just going to follow up. I threw a couple of links in the chat as well, a tool for work that's very similar to this. I'm not sure that trying to solve all of these problems with a single solution is going to make sense. Like the third-party API one, you might want to think about, what Kelly from MITRE was talking about in cross domains, if those are truly third parties that I'm reaching out to, and how that might be a better solution as it relates to the token management. But for sure, the top 2 or 3 things, I've seen a couple of things. One of them's from Netflix. One of them was a talk I gave at Identiverse in 2019. So I think there's thoughts in the space. I would agree with you. I don't know of any standard that exists today, but I think we have a lot of things to build on.
That's great. I'll look them up. I'm obviously not familiar with the Netflix implementation, but yeah, I'd love to take a look. So yeah, I think the real question is, is this something that everyone can benefit from standardization, right? And that's sort of the open question I wanted to bring up in this talk today.
Any other? Yeah, go ahead.
Yeah, I hope you're here this week, so that may give us a chance to socialize and discuss and to dig deeper into those aspects and see where some of the folks in the room have actually thought about solutions already or have run into similar challenges. And so I think it's a good conversation starter. Yeah.
Right. Yeah. And informally, I've spoken to some folks at one of the big platform providers, AWS, and they seem to have interest in standardizing. I think Peter and I also talked about this. There seems to be some interest from Google very early, so things may be sort of going in the right direction, but this is a good week for me to have discussions and sort of bring it up a little bit in terms of mindshare.
Yeah, and that's great. I think obviously you're welcome to come back after that, and if you have a solution in mind and you want to discuss, you're always welcome to that.
Yeah, sure. Thanks, everyone. Maybe in one of the successful meetings, we can sort of go into some detail.
Sure.
Of potential solution.
Yeah, if needed, yeah, we can do that. Sounds good.
Thank you.
Okay. I think we are 1 minute. Any other business? Any other comments, questions? Okay, well, thank you all. We're done.
All right.